What is happening with your microphone?
Hello, teacher.
Yeah, Mario. Very special voice. Um, what is the structure in diamond?
Structure in diamond.
Yeah, diamond has covalent bonding. It is correct. Atta already told us the answer. It has covalent bonding. It's correct. And then what is the structure? Molecular structure of diamond, of iodine. Yes.
Hmm,
Molecular structure.
I don't know, teacher.
Ah, molecular structure in time in iodine is simple molecular structure. Simple molecular structure. Then let me ask to Valentino. Hello, Valentino. Are you there?
Yes, teacher.
Okay, Valentino. Uh, what is the structure of diamond? If iodine has simple molecular structure, then how about diamond? Yes.
I don't know the answer, teacher.
Uh, the diamond, the structure of diamond is giant covalent network. Okay, giant covalent network. And then later I will tell you the discussion of this one. Now number three, there is a white phosphorus and red phosphorus. White phosphorus has the melting point of 44, while the red phosphorus has melting point above 550. And then, so in here asking what is the meaning by the term macromolecular. Okay, let me ask to Matthew Dharma. Matthew D. Hello.
Yes, sir.
Yeah, Matthew, what is the meaning by macromolecular?
Macromolecule, sir.
Yes.
Uh, so a molecule that contains a large number of atoms.
Okay, molecule that contains large number of molecule.
Large number of atoms.
Okay. This one, macromolecular is giant ionic structure. Okay. Wait, let me. I would like to go to toilet for a moment. Then this one, between red phosphorus and white phosphorus, the macromolecular. We know that macromolecular is like in giant covalent network and also in metallic lattice. And then this one, the by considering the structure and bonding of these two forms of phosphorus, so for the same element, one element that has two different forms, two different structure. What are those structure? One is simple molecular structure and the other one is giant covalent network. How come it is simple molecular structure? Simple molecular structure uh, because the that one has the white phosphorus has melting point below 100 degrees Celsius. If below 100 degrees Celsius, then the white phosphorus has the simple molecular structure. Okay, while red phosphorus has giant covalent network because it has high melting point, and these two phosphorus they are called as allotropes. And then next number, on the next number, this one have to draw the shapes of the molecule, and also next number here, number B, white perfume is using solvent, and then the solvent, once it is evaporated, it causes the skin to cool for a short time, and then the fragrance can be detected from some distance away. This one, uh, this one has the process of diffusion. And then last number, in the last number, there is between iodine and graphite, and then we have to tell about the shape of the BCl2 molecule and explain why it has this shape. Okay, uh, so I'm going to take attendance before I continue to the more discussion. Let me take attendance. This one. Okay, of today 11 p. 11 p. Today there is no Alicia, Alberto, Andrew. Where is Andrew? I do not see Andrew. Andrew is absent. Andrew is absent. Carlton is not here. And then Eiffel. Eiffel is also away. Eiffel. And then Hayato here. Janice is absent. Okay, so Janice is absent, and then Kayla is here, and then Kevin P is here, Kevin N is here, Mario is here, and then Maximilian Max is here, and then Matthew here, Nia is here, Rizky absent, Saka absent, Sarah absent, Shannon is here, and Valentino is here. Okay, I would like to share my discussion. Okay, I'd like to share my discussion for the solid, liquid, and gas worksheet, yesterday's worksheet. Let us discuss the worksheet. Okay, discuss the worksheet. Let me share Okay, let me share. Let's us discuss the worksheet of yesterday about the solid, liquid, and gas, especially about solid and liquid. We know in solid and liquid there are some structures, simple molecular structures, giant molecular structures, lattice structures, and then also giant ionic lattice, and then metallic lattice. Okay, so let's see in this one. This worksheet is specially made for grade 11 for solid liquid only. Let's see number 1. Diamond and graphite are both forms of carbon. Diamond is able to scratch almost all other substances, while graphite may be used as a lubricant. Diamond and graphite both have high melting points. Explain each of these properties of diamond and graphite in terms of the structure and bonding. So in this one, the question is asking specific to the terms and bonding of diamond and graphite. Did one other difference in the properties of diamond and graphite? Okay, in structure and bonding, we know in structure, diamond is hard. So let's discuss from the perspective of structure and hardness. Both of them are macromolecular, giant covalent network. The difference is in diamond, the one carbon atom, is joined to 4 different carbon atoms. It forms a tetrahedral shape with a bond angle of 109.5 degrees. The coordination number is 4. How come coordination number is 4? Because around carbon there are another 4 carbon atoms. And then in graphite, one carbon is surrounded or bonded to other 3 carbon atoms. And then because there is one half lone pair, and there are 3 bond pairs only, with only half lone pair. So we can call that this shape of the molecule is trigonal planar. Because one carbon is surrounded or bonded to other 3 carbon atoms, so we call this structure has coordination number of 3. And then diamond is a crystal, and then it is strong. It is stronger than graphite. And then according to the 3D structure, that we used to learn in grade 9, diamond has tetrahedral shape, but tetrahedral structure, but in graphite has layers of hexagonal. The layers are connected by van der Waals forces that makes the layer able to slide over each other, and then this graphite is not as strong as diamond, but it has high melting points similar to diamond. Why? Because both of them have a giant covalent network, and then giant covalent network requires high temperature to overcome the strength of the covalent bonds. And then one more difference that we already learned in grade 9, diamond cannot conduct electricity, but graphite conducts electricity because there is a free electron. In diamond, all the electrons are occupied, so there is no free electron. Okay, then now let's continue to number 2. Iodine and diamond are both solids at room temperature. Okay, this is a fact. But iodine is a volatile solid. which is at higher temperature, it can evaporate directly. But diamond in temperature maybe 100, still not yet become anything, still solid. It does not become liquid or become gas, different from iodine. Identify one similarity in the bonding and one difference in the structures of these two solids. Explain why these two solids have very different melting points. Okay, let's see from the perspective of the bonding. Both of them, diamond and iodine, they have covalent bonding, the intramolecular forces. The difference is in the structure. Iodine has a simple molecular structure because it has lower it has a lower boiling and melting point compared to diamond. Diamond has very high melting and boiling point that makes it has a giant covalent network. It has strong covalent bonds, but in terms of the bonding, both of them have the same covalent bond. And then iodine has a instantaneous dipole, or called as weak van der Waals, or called as induced dipole forces, because iodine molecule has no electronegativity difference. One iodine atom has a certain electronegativity which is chemically combined with the other uh, iodine atom that has the same electronegativity value. So when they combine chemically, there is no electronegativity difference. If there is no electronegativity difference, then this iodine molecule has an instantaneous dipole-dipole process that makes it has a low melting and boiling point. While diamond has a giant covalent network, it has the tetrahedral structure that has a strong bonds. So it requires high temperature to overcome the strength of the bonding. Number 3. Phosphorus exists in several forms, two of which are white phosphorus and red phosphorus. White phosphorus consists of P4 molecules, melts at 44 degrees Celsius. Red phosphorus is macromolecular, has a melting point above 550. So these two phosphorus came from the same phosphorus but different forms. So we can call this one is an allotrope of phosphorus. So here we can see from the first sentence here that white phosphorus has a simple molecular structure because it has low melting and low melting point compared to red phosphorus. Red phosphorus has a giant covalent network because the melting point is more than 100 degrees Celsius. So the question is asking, explain what is meant by the term macromolecular. We know what is the meaning by macromolecular is giant covalent network. It forms a giant covalent structure or giant structure. By considering the structure and bonding present in these two forms of phosphorus, explain why the melting point are so different. Melting point, as we know, as I told you, that that white phosphorus has a simple molecular structure, while red phosphorus has a strong giant covalent network, and it has and white phosphorus has simple molecular structure. It has weak van der Waals, but in red phosphorus it has also van der Waals, but stronger van der Waals. Okay, number 4. Predict the shape of sulfur hexafluoride molecule and NaCl4 negative ion. we have to draw the diagram of each species in their three-dimensional shapes. Name the shape and suggest the value for the bone angles. We know that as in SF6 has a shape of octahedral or square based by pyramid, not square pyramid, but square based by pyramid. So there are two square based pyramid that joins together become an octahedral with the bone angle of 180 and 90 degrees. So the shape is like this. We know that in SF6 there are 6 bone pairs and without any lone pairs. And then in AlCl4 negative, the shape is like this. This Al atom, aluminum atom in the center. There are 4 here, and then the shape is tetrahedral with the bone angle of 109.5 degrees. Okay, and from the AlCl4 here, we know that there are 4 bone pairs and without any lone pairs. And then B. Perfume is a mixture of fragrant compounds dissolved in volatile solvent. When applied to the skin, the solvent evaporates, causing the skin to cool for a short time. This one, what is the volatile solvent? Is alcohol. After a while, the fragrance may be detected some distance away. Explain these observations. The fragrance may be detected some distance away. It is called as diffusion process. Okay, and then because it has a volatile solvent, so the solvent has low melting and boiling point. If it has low melting and boiling point, then it must have a weak intermolecular force. What is the weak intermolecular force? It is the weak van der Waals. Okay, and then so the process is, why is it cool? Because there is a endothermic. Higher energy or faster molecules directly escape, so the mean energy falls. So that makes the energy taken from the skin, so it cools. We know that endothermic is energy given in to the surrounding. Okay, given in by the surrounding. So it is the opposite from the exothermic. Exothermic is energy given out to the surrounding. This one given in, and then by random movement diffusion, there is the fragrance can be detected some distance away. Now let's discuss number 5. Iodine and graphite. So in previous number it was a question about iodine and diamond, but this number 5 about iodine and graphite. Crystals both contain covalent bonds, and yet physical properties of their crystals are very different. For iodine and graphite, state and explain the differences in their melting points and in their electrical conductivities. In iodine is easy to sublime, while graphite is not easy to sublime. It has high melting point. If it has high melting point, so the intermolecular forces in graphite is stronger than the intermolecular forces in iodine. Iodine has a very weak intermolecular forces compared to graphite. And iodine has a simple molecular structure, while graphite has giant covalent network. Okay, so according to the theory, it must be about the intermolecular forces that determines the low melting and boiling points. So then B, draw the shape of the beryllium chloride molecule and explain why it has this shape. So the diagram, so there has to be Be in the center, the Cl surrounded B. Okay. In BeCl2, there are two bond pairs without any lone pairs. If two bond pairs without any lone pairs, then the bond angle is 180 degrees with the shape of linear. So these are the discussion of the question for this worksheet, solid, liquid, and gas. Okay, so I already discussed this one, so I hope you already do the worksheet and submit. Okay, is there any question regarding this one? Let me share again. Yeah. Is there any question for this one? Hello. Let me ask to. Okay, let me ask to Hayato. Hello, Hayato.
Yes.
Now, Hayato, let me ask, what is the process called when fragrance may be detected some distance away? What is the name of the process? Yes?
What is the question again, sir?
Yeah. What is the name of the process in number 4? And number 4B. Number 4B, there is a fragrance may be detected some distance away. What is the name of the process? Yes? What is the name of the process? Hayato? The name of the process is called as diffusion. I don't know whether you were listening or just putting the mobile phone. But I hope you have to listen to the discussion, not only considering it as a sounds for the ears. Okay, so please listen attentively for the discussion. Okay, so WebEx is going to shut down by itself. So we will discuss again tomorrow. Do not forget to do the today's sheet.
Thank you, teacher.
Yes, you're welcome.